So today we're going to work through a problem using Solver. I have a student here with me to ask questions as I go through, so sometimes I forget that it's good to explain some of the things I think of as basic. So he's agreed to help me. Any questions he has doesn't mean he doesn't know it, it just means it's a common question where he's helping me out with that, so I appreciate that. The problem that I'm getting comes from the Microsoft website here on their blog. Here is the address. I'll try to put a link in the comments as well for you. But it's a small job shop needs to schedule 6 jobs. The due date and days needed to complete each job are given below. In what order should the jobs be scheduled to minimize the total days the jobs are late? So looking at the website that we have here, if we go down here is the problem, and you'll see the 6 jobs are listed along with the processing time, and the due date is measured from today. You can either download that file or you can just copy and paste this in to the spreadsheet. Now I already have it there, but if I just wanted to copy it and paste it, you can see that it pastes in really nice and easy. As a matter of fact, let's just go ahead and use what they had just so that we're starting totally from scratch. I'm going to go down here and put some notes, and the first note I'm going to put is due date measured from today, and up here I will put due date, and then that way that shortens that a little bit, and then processing time is fine. Let's wrap those so they show a little bit better. I'm going to go ahead and center it. Sometimes you don't center just so it stays left aligned so you know it's text, but in this case I'll center it because we can tell it's text there. So the first thing that I want to do is not really Excel, it's more critical thinking and problem solving. I'm just going to go through this line by line, and I'm going to say a small job shop needs to schedule 6 jobs. Okay, that's the first thing there. So let's look through, and there's the 6 jobs. That makes sense. We see how they're scheduling it. We read this to understand what's happening. The due date and days needed to complete each job are also given. We see the due date, and we know that's measured from today, and we see the processing time, and we know that the processing time is the days needed to complete each job. Okay, so let's see, let's just unwrap that so it goes across there. Okay, so processing time, days needed. Okay, so we got that. In what order should the jobs be scheduled to minimize the total days the jobs are late? Okay, so we're going to want to return the order to schedule the jobs in. So we can either do that in a separate table or we can do it out beside here. I'm going to do it beside to start with, although we will probably so what you call this doesn't matter as long as it makes sense to you. This could be called job order. Matter of fact, let's just call that job order. That makes more sense than sequence. Okay, so there's my job order. Okay, and for now, I'm just going to go through and put them that we're just going to run them in the order they're listed. That's not going to be our final answer. That's what we're going to put there. So the total days late. Okay. So I'm going to need days late. So to get the total days late, I need to know how late each job is going to be. So days late and total. So my total days late is just the sum of the days late each job is late. Okay? So in order to know how late each job is, I'm going to have to look at the due date and then how many days until it gets done. So I'm going to have to move this over. I would actually move it over 2 or 3 columns. You can just move it over 1 as you add each thing, or go ahead and put it over there just so we know where it is. So next thing I'm going to put is days until done. Okay. I don't like that title, but let's just go ahead and go with that now. And the days until done is going to be the number of days that it takes for the job to be done. Okay. So that's going to equal the number of days it takes for the job to be done. Now that's going to be based off of the job order. So since we're basing off the job order and this number can change, we can't just refer over to processing time to do the days until done. We have to know which job we run first, because once again this will change. So with that being the case, to avoid confusion, I'm going to go ahead and now I'm going to put this down below. Once again, you don't have to. I'm just showing you a logical way to do this. You could move it later for readability. That's not as important as just understanding the process. So just bolding my title so I can see it. So days until done is based off the job order. In order to get that, we're going to have to look up which job we're running, look at processing time. Now, since we're looking up, we're going to use a lookup function. We could do Vlookup, HLOOKUP, or the match index. In this case, let's go with either Vlookup or HLOOKUP, since those are a little bit easier to understand. And we're going to do the Vlookup because our data is vertical. You see each instance here is listed vertically. If the data was listed horizontally, we would use HLOOKUP. So if the data was listed like that instead, then that would be the HLOOKUP, but it's not. So Vlookup is what we're going to use. So days until done. Just to make this easier and not have to deal with absolute, relative, or mixed references, I'm going to name my table down here. When I make a table on this, I do not include the header row. And for my table, I am going to name that, let's see, let's just name that TBL job. You could just name it job table, whatever you want to name it along those lines. So that is my table. I will double check, make sure it's right. Yep, it's the right range there. So days until done equals Vlookup. Okay, I'm going to look up whichever job I run, and I'm going to look it up in my job table. Okay, and I want to return the processing time. That's how many days it will be until it gets done, is that processing time. So that's the second column. And I want to do an exact match. I could do exact or approximate. It doesn't particularly matter here. I'm going to do exact so that way if there's a number that is different in there, that it'll alert me with an error message. Okay, and we see that for job 1 it would be 9 days. I'll double check this and just put 4, and that should change to an 18, and it does. So my function is good there. Now I could just copy this down, and we will, as a matter of fact, and you'll see it just gives me the values here. However, that days until done, that's for the first job. Okay, the second job is going to be done after the completion of the first job, since we can only do one at a time with our machine because we're a small shop. So we're going to say that it's going to be equal to this Vlookup that we have here. Okay, and then in addition to that, we are going to add the sum of what came before it. Okay, sorry, of B $14 through B 14 end. Okay, so there's another way to do this that I'll show you as well, but when I pull that down, what you'll see happens is that, yeah, actually that's not how I want to do it, so strike that, sorry. Instead of doing it that way, let's do this. Yeah, that would work if I was doing this a little bit different. Instead, we're just going to add the previous total time, and that will work. Okay, and then, so that's the total days until done right there. Okay. We also need to know the days to complete job, and okay, sorry. The days complete jobs, that's for each job, and then that's the total. That's just this and that combined. That's just these two plus that combined, so on and so forth. Okay, so that keeps the running total of the days complete. Um, and once again, we're working this as we go, so sorry for the stops and starts, but that's just kind of how this is done, is you figure it out as you go, to an extent. Okay. Um, and then due date. Okay, and the due date comes from up above. So, tell you what, instead of doing that, I'm just going to do it from scratch just to redo it. So Vlookup, I'm looking up the job there that we're going to run, and I'm looking that up in my same table we used earlier. In this case, the due date's the third column, so I want to do a 3 instead of a 2 there. I'm still going to do a false in here. And that gives me the due date. Okay? Now, the days late is simply when it's due minus the days until it's done. Okay? So that gives me how many days late this is. Wrong order. Okay. So that's a negative number because that we're getting it done ahead of schedule. We don't get credit for getting it done ahead of schedule. So what we'll need to do is to put something in there that will check for us to make sure that our first number is greater than our second number. So let's just do a quick if C14 is greater than D14, then we're going to do that. Otherwise, we just want a 0 in there. Okay? And everything copies down. So what that does is that gets rid of the negative numbers for us. Okay? Okay. So, so now we go through and let's see what all we have here. We're looking at the days until done. I made that harder than it has to be, sorry. What I can do with that is I can just say that equals that equals that plus that. And then that way we're looking at the days we are at now, and then we're adding the next one to it. So comes out the same as the other way. Either way is fine. Okay. So that's our days until done. And then that's our total days late on that, which we want to minimize our total days late when we look up here of, you see our stated objective there is we're trying to minimize the total days late. Okay. So, once again, what we have is that at this point for the job order, I can go through and let's say instead of running them 1 through 6, I want to, and before I do that, let's just look at how many days late we are right now. So if we run it 1 through 6, we're going to be 66 days late. Well, what if we ran job 6 first, then 5, 4, 3, 2, 1. We made things worse. It's 75 days late. What if we did 1, 5, 3, 2, 4, 1, 2, 3, 4, 5, 6. We're at 67. We're still worse. So we could keep going through and trying a few million combinations to figure out what the best one is. However, we want to get this done in this lifetime. So we're going to go ahead and we're going to use Solver to optimize this for us. Okay, if you haven't installed Solver, that's a different tutorial, but you need Solver installed to do this. So I'm going to go over to Solver, and Solver must be a single cell on the active sheet. Okay. I've got Solver open in another window is the problem right now. If you get that error, that's the problem. Um, the um, so okay, so I had to go through and quit the other program. Sorry about that. I had worked this in a different window before we're doing this. So now let's go ahead and run Solver, and we want to minimize this value, and we're going to change the job order in order to minimize the value. Okay. And the constraint that we want to put on here is that we want to make sure that every one of those is different. Okay, 1 through 6. So we're minimizing this by changing the job order. So minimizing this by changing the job order, and we want each one to be different. That way it doesn't just schedule the shortest job repeatedly. Otherwise, if we just scheduled job 6 all 6 times, we'd come up with 36. So that would be the um, probably the that'd probably be the way that would give us the least. Now we have to figure out which type of equation we're doing. If the formulas we're varying are based on multiplication, that's going to be a linear function. So like the y equals mx plus the intercept and everything, then that would be a simplex linear program. For a smooth line that's not linear, we would use the GRG nonlinear. For a problem that's going to kind of have the answer jump around a lot, we'll use evolutionary. In this case, evolutionary fits what we're doing. Let's go through and look at our options. So for evolutionary, our convergence, you can change this down just a little bit if you want to, or leave it at the default. Mutation rate, I changed to 0.5. That's just how much variable there'll be between guesses the machine's making, so you can put that if you want. Changing the random seed changes where it starts at. Your answer should still come out the same unless there's multiple answers, in which case changing the random seed can make the answer come out different. The maximum time without improvement, that's going to depend on your problem somewhat and how big your domain space is. So once after it goes for 30 seconds without improving, then it will return and answer is what the 30 is. I'm going to go ahead and just put that down to 10 seconds just so I don't have to wait quite as long. So we have all that done, and yeah, everything looks good on this. So let's go ahead and run it. Okay, everything looks good. So solve, and somehow I had changed from that to up there when I clicked over as I was explaining. Sorry. So when we solve this, we go through, and instead of an optimal days late of 67, we come up with an optimal days late of 38, and that's from running job 2, 6, 3, 1, 5, and then 4 in that order. So you can see how that going through there, it helps us um, to be able to make it where that the days late is able to be minimized. Now, that is the end of how to do this problem for the way it was written. At this point, I'm going to go ahead and play with this just a little bit. I've not done this before, so this is just seeing what if we want to change some other things. So Let's try putting another constraint on here. And for this, for the days late, what if we want to go through and we want to say that um, we want those to be equal to or less than 30 days. So we don't want anything to be more than 30 days late if possible. I'm going to pause. Okay, so we come up with the, oh, sorry. Okay. You saw that we came up with the so as I say, it comes up with 47, and none of these are 30 days or more past due, so that would be an option as well. What if we wanted to go through and do this with a shorter period of time than 30? Then we can change that, and we don't want it to be more than 2 weeks late. I'm not sure this will have a solution. It might get to the point where there's no solution. If it does, that's fine. That just lets us know that that's not possible. Okay, so we see that Solver could not find a feasible solution. So it didn't find anything that met the parameters we want. If we look down here, we will see that it was able to get it down to 20. So let's try 21. What if we want to do 3? We know there's a solution that way, so that should work fine. So we're just going to change this and put our constraint towards 21. Okay. And that is our solution for having it where that none of these are less or later than more than 3 weeks. So we've got a choice to make there between the two solutions that we tried. If I wanted to, since I've used my absolute or mixed references, I could simply copy that, paste it down here. It will still work, and we'll just say this is to minimize days late, none more than 3 weeks. Okay, and minimize days late. Okay, so if I just want to minimize the days late, we'll go into Solver. We'll get rid of that constraint there. Solve. Okay, so looking at that, we'll see that we got our 38 answer there that has one job being over a month late. And then with this, we can go through and set that equal to the 20 days late, or 3 weeks or less. Try something here I don't think will work, but let's just give this a shot real quick. Let's add a rule in here that okay, good, I can do it this way. So, and instead of that, I'm going to say 30 days because of that being a month. So, and I'm going to put that as a reference there. And pretty cool here, but you'll see that we can put the number of days that we're willing for it to be late in here when we run Solver. And then that way we can just run Solver repeatedly. Not going into macros, but we could do a macro that would run Solver for us and allow us to input that number as well. So, so some different ways to do it. Looking at this actually might be a little bit better way because no one's more than the 3 days, or 3 weeks rather, late. but you'd have to look and see that maybe you renegotiate something with them instead and everyone's happy. But that's a business decision. What this is the intelligence for you to base the decision on. With that, I will end this. Have a great day.